I'm Mike Farrell. As you said, I'm with Northeastern University, heading up a new publication that's about ready to launch, all about the future of work. But we're here to talk about artificial intelligence, which is going to greatly impact the future of work. We're a fairly intimate group today, so hopefully this will be a very interactive conversation. And we've got some great people here to discuss AI and where that's taking us. To my immediate left is Dr. Catherine Havasi. She is she was at MIT Media Lab and is now running a company that's spun out of MIT Media Lab called Luminoso. And she's going to tell us a little bit about what they do, but basically it's an AI-based natural language understanding technology, and they're in Cambridge. To her left is Byron Galbraith. He is with another AI company, co-founder and chief data scientist at Tala. And if you've ever interacted with a chatbot on the internet, they may have the technology behind that. He'll tell us a little bit about that. And to his left is Dr. Keith Dreyer. He's the vice chairman of radiology and the director of the Center for Clinical Data Science at MGH. And we'll get into whether or not AI will eventually even replace radiology at some point. So maybe he'll be out of a job, I'll be out of a job, computers will be doing everything. So we'll just get right into like, what is AI? Can AI prevent this echo? Next time we're in this room, perhaps. So I'll let Catherine sort of walk us through some of the terminology around AI, machine learning, and what that it really is, and kind of break down the terms.
Hi, everybody. Thank you all for coming. So I'm going to talk a little bit really quickly about artificial intelligence, machine learning, cognitive, deep learning, and what all those things are. When people talk about artificial intelligence in business, they're typically talking about what we like to call pragmatic artificial intelligence. So that basically means AI that's very good at a specific task. So it's at, or sometimes well better than human performance at doing something that people can do, or maybe people can't do, but it's really focused on a specific outcome. There's something called artificial general intelligence, which is what people think of when they see movies about AI. It's walking around, it's talking to you, it's doing a lot of different things. That's not the kind of thing we're going to primarily talk about. When people talk about machine learning, it's a way of using algorithms to really understand and learn and adapt around data or around functionality. When people say deep learning, nobody knows really what that is. It's a type of machine learning that is really good at finding and extending and understanding relationships between patterns. So cognitive is really another way of saying AI without the baggage. Is machine learning AI? I'd say yes. I think we have machine learning in everything from our email to our search. It's really about how can we do the more mathematical side of AI? How can we really just use algorithms to teach computers things?
Now, there's some, I mean, the terms get overused and mixed up, and you know, people like me in the media will write headlines that are, you know, fake news, to borrow the president's favorite term. I mean, could you talk about a little bit, maybe Byron, some of the confusion around AI, and maybe there's something that we're interacting with when we think it's AI, whether it's our phone, whether it's some technology online that's really not AI?
Yeah, so we've got devices, like, you know, we were talking earlier before this, you know, is the smartphone in your pocket, is that AI? Is that artificial intelligence? Is a calculator which can do, you know, arithmetic way better than you or I, is that AI? And so where we encounter these things, whether it's a machine learning algorithm that has learned how to do something, or just a simple expert system that was just a sequence of rules, something like a clinical decision support system, or a dialogue system where you're chatting with dialogue, a chatbot that's just like a sequence of rules. It's really hard to say, like, what are we talking to? Like, we could have AI everywhere, right? Like, every phone, every smart device out there, artificial intelligence. And so this distinction that Catherine made about AGI versus AI, like, we're not going to see, androids walking around doing a large variety of things when we'd say, oh yeah, that's AI. But we really have, with all of these smart connected devices out there, it's really, in some sense, everywhere.
So Keith, walk us through when we walk into MGH or we're in the radiology department or we're talking to our doctor, where are some of the places where patients are encountering this kind of technology?
Right, so I agree with what the others have said, is that AI is kind of a pervasive solution that comes into play. Like, if it is in your phone and it's helping you to do search inside of your images, is that AI or is that just an enhanced application? So it's the same thing that's happening in medicine that we see. So if it's helping the clinician or the radiologist at the time of interpretation, it might be doing so by finding difficult lesions for me, or quantifying those lesions, characterizing them, helping me with management pathways, which is called decision support, or it could be embedded inside of the devices. So I wouldn't limit my thought to say that AI is going to, as you say, sit in a robot. It's going to look, I think, much different than that. Devices are already highly sophisticated, and just to add some machine learning into them to make them smarter or to make them make better decisions is how I see it becoming much more pervasive. So to your question, how would you see this happening inside of our organization? If you came into the emergency room and you had a CT of the head performed, you can imagine that inside the scanner or as a separate system, it would analyze the brain, see if there's any blood, stroke, mass, tumor, and be able to give that additional information, not unique only information, but additional information to that clinician that's then caring for the patient. That's where we're at in 2017. In 2077, might it be more automatic than that? Possibly. But for the next decade or two, I see this as an adjunct to what it is that we do.
And have you seen, has there been any studies, research done on like the results that a radiologist will get when using AI versus just, good old-fashioned looking at the X-ray kind of?
Yeah, so the studies that are being done today, I look at AI in two different ways when it's application to medicine. It's what you can do that humans already do in a more accurate way, more efficient way, more consistent way, because when humans do it, we all have our own AI running or intelligence running in our brain, but it's separate from each other. So it creates this uniformity that we don't necessarily have in healthcare today. The second piece of it is it could do things that humans can't do today. The challenge with that in 2017 is that you have to have an endpoint. Typically, you have to be able to have supervised learning. And to do that, you have to have ground truth, so you have to know what the outcome is. Well, if the outcome today isn't being created by humans, then it takes a lot more work to get to that outcome, to train the algorithms. So today, what I think you'll see is the combination of humans and the algorithms. And to your question about, is it helping from a value standpoint, when you submit to the FDA for regulatory approval of these devices, you not only have to show value, but you have to show, safety, but you have to show value. So in theory, these algorithms are approved when they can demonstrate that they're safe, but they're also adding value. So just by definition of the regulatory approval process, they are intrinsically adding value. But I can tell you also from studies that we've done, we can clearly see that when humans and the algorithms combine, that you do get improved value, however you measure that, by efficiency, accuracy, outcomes, et cetera.
So you talked about a little bit about how doctors are interacting with the technology. So are there particular uses where right now AI is taking work away from people, or allowing people in any profession really to like focus on something else and to really improve the overall productivity?
So one of the things, what our company does is customer service, helping customer service be better and more effective, as well as more informative for companies. And what is typically done in something like a contact center is that when a rep gets a call, you don't have a lot of information about you. You've all called in and they've told you to, basically turn it on, turn it off, did that work? And they should know from your history that you already tried that. So in a way, it's not necessarily taking work away to give the rep information about you or to tell you, hey, here's the web page that answers your question. But it allows people to focus on the deeper interactions where you really want to walk through 401k strategy with someone and get away from the interactions where you want to reset your password.
I would add that if you look at healthcare, particularly in diagnostics as I'm in, over the last 20, 25 years, we've gone from analog to digital. And what that's done is it allowed us to be much more efficient in getting data to us. But we have considerably more data now that we have to analyze. So if we have to get through the same number of cases in a day, and we have more information coming to us, we have less time to interrogate that data that's coming in. So I look at these tools initially, or one value that we can add with these tools is the ability to aggregate that data and give some deeper meaning to that data that we don't have today, or we would have to infer from interrogating deeper amounts of data. So the digital aspect of this made us more efficient, but I think adding AI to it will make us more accurate.
And just to touch on that, I think, we've talked, and Keith mentioned this idea that, the AI, what it's really doing for people is it's sort of solving one of two, I'd say, broad things. It's either making you more efficient, or it's unlocking new affordances, new things you couldn't do before. And so, for instance, like again, in the case of customer service, or in our company, we look at internal service organizations like IT or HR. How do you let them spend more of their time on harder, more difficult problems, essentially the reason you want them there, and not doing things like reading the intranet to their employees, or reading the employee handbook to their employees, because the person who wants information just wants someone who knows the answer to tell them. They don't want to go look for it sometimes. So if you're losing all of your time to sort of these easily automatable tasks, this is a great place for something like AI to just unlock your ability and the employee's ability to do more specialized or more meaningful work.
We've all seen the stats about how many jobs robots will be replacing in 15 years. I think the latest one I saw was something like 30% of all jobs could be impacted by robots. I'm all in favor of that, so that's fine with me. But a lot of people aren't. But be happy for the robot to edit my stories that I have to edit. But anyways, I mean, it seems to me that those numbers are grossly overstated. I mean, where do you think we are in this action within the growth of AI, that we can become smart enough to really do someone's job full time? And what sort of jobs are we talking about?
All the time, technology is changing and rendering jobs obsolete and bringing in new jobs, right? So as we see these things happen, we're also going to see a lot more jobs coming to fruition, things that have to do with everything from the capabilities that have been unlocked by AI to jobs like becoming and writing the personalities for intelligent agents, which is something that nobody would have done for a living maybe 2 or 3 years ago. We're never going to imagine what these things are. And I think with that, we have more time to do more creative jobs and more people-focused jobs, which really we're pretty far away from AIG, which we need to automate those types of systems.
I would say in a previous session in Faneuil Hall this morning, Tina was there up on the panel, there was a video shown of Jeff Hinton, one of the fathers of AI or machine learning, had said, we should stop training radiologists now. It's completely obvious that AI is going to be more accurate than radiologists, so let's stop training them now. Now, that was in about a year ago, it was 11 months ago. About 2 weeks ago, he said, we're actually taking the wrong approach to machine learning, and this deep learning stuff has got too much dependency on annotated data, and we have to start over. So imagine if we listened 11 months ago and we stopped training radiologists. There's a crisis right now in Scotland where there are not enough radiologists. So there's all the technology you want, but it takes a decade to train a radiologist. So if we just, on the whim, just stop, this changes healthcare considerably. So I think we need to take, as healthcare does, and I'm a technocrat, but healthcare is very conservative, and I think probably for good reason that we are. So I think the adoption of these tools are probably going to happen so slowly, meaning that over 20 years instead of 2, that people will have to transform. The jobs will transform, and the roles that they play will transform. We put in technology, speech recognition, where before we had 50 transcriptionists doing the work in one department, where we have no transcriptionists today. So I think it's reasonable. It'd be irresponsible to say that technology will never replace a job. But I think it's also equally irresponsible to say this technology will replace all jobs where people think. It just doesn't make sense to me.
Yeah, it's the timeline to your, I think, original question too is sort of grossly over-optimistic, if you will, and actually the current state and progress of the technologies. There are tremendous aspects of things about jobs and the distribution of those jobs in various societies that a machine that can do, say, image recognition is not really going to replace. Again, you need the expertise to train these systems. We are seeing more people getting into this idea of machine learning or AI trainers. Like, okay, we need labeled data. I need you to tell me what this is so that an AI can learn how to do that particular task.
I need you to build the interaction patterns for the intelligent agents.
Exactly. So, we're seeing more like, just how do you make these things actually useful? We need a lot of people to convey a lot of specialized information to make that happen.
Seems like, Catherine, go ahead.
I was going to say, I think there are industries that are going to be very impacted. I think supply chain is going to change and has been changing a lot, both inside warehouses with the use of automation, but also the impact of self-driving cars on trucks and truck trains. So there are going to be places where there are going to be big changes, but all jobs across all sectors is not something I would jump to right now.
So there's a lot of times when we're interacting with AI from the consumer point of view, we have no idea that it's really going on in the back end, whether we're on social media or just somewhere on the internet or we're in a doctor's office. So how can we begin to give consumers more transparency on how machines are more and more making decisions about our lives?
That's an excellent and very difficult question. I mean, because to some extent, how do we know why people are doing what they're doing? We think that maybe because a machine was crafted and created by a human, that it is somehow entirely inspectable and interpretable, and we can unpack it and dig around and say, okay, this is why this thing behaved the way it did. It's a big challenge with a lot of these current methods in that they are somewhat uninterpretable, or they're very difficult to convey why they're doing what they're doing in a way that makes sense to anybody. They tend to be trained on large, say, sets of data, and so you're getting sort of statistical behaviors in aggregate, but why do you as an individual get slotted into some, outcome can be very hard to understand.
In AI, this is often called the explainability problem, and it's going to be really critical to adoption and to AI becoming part of the chain. And I think right now a lot of AI is explained with justification. So going back and saying, oh, I said this was true because I can see this pattern and I can see this pattern, and these are a bunch of things I can back it up with. But actually being able to explain, that's something that everybody's working on right now. We're working really hard on it. We have some good, interesting results. But it's going to be really required in a lot of fields, especially medical fields, before people use this in a widespread way. Customer service is one thing, radiology is another.
I think, so I'm on the board of the American College of Radiology, and we speak with the FDA quite frequently. And one of the concerns I have, imagine if you went in to get a CAT scan or an MRI, and each hospital was different in the way that they examined you and scanned you, and radiation dose and all of these things that are somewhat under regulatory control. So my fear is that we look at this as software. It's much more sophisticated than software of 20 years ago, but we're trying to regulate it like software. And yet we regulate humans much differently. So if this is going to become close to human capabilities, even in a narrow sense, then shouldn't we have a better definition of what it is that it's performing from a transparent standpoint? One is explicability. Why did it say what it said? But the other one is, how do I know when I go to one of 50 different hospitals that something the same is going to happen to me? And I look at that back on us. I mean, these machines aren't going to do it themselves. Humans have to define that. So in our space, we're tightly defining what it is that those narrow AI functions should be. Think of it as like an autonomous vehicle. I don't think the day is going to come tomorrow where cars are going to be driving themselves for a variety of reasons. So there will be features and functions that they do, like lane assist, collision avoidance. We need to have that same kind of definition inside of healthcare, and today it just doesn't exist.
So where are regulators on looking at AI in the medical space? Are they caught up? Are they trying to catch up?
Who is
are they
this?
behind?
I'm sorry?
Regulators?
Oh, there are some challenges. It happens so quick. This is all in the last 5 years, really. So I think some of the biggest challenges are around self-learning, continuous learning systems. Because the way that the FDA works, and you probably want them to work, is that a device gets created, you test it against a known world experience, you demonstrate the value, and you demonstrate the safety, and then they pass approval, not approval. Well, if that device is continuously changing, how could you predict in the future how to regulate or approve that device? So the FDA is actively, highly actively thinking about this in ways that would maybe decrease the pre-market approval process, but increase the process around post-market surveillance. So what's happening out there in the wild when these algorithms go out? Is there something different on the East Coast or the West Coast or in country A or country B? And is it changing when the data changes? Is it changing when the population changes? Is it changes when new diseases come in? So I think this is going to, if anything, that this is going to create the new era of, it's going to be regulators monitoring continuously, as opposed to previously it was pre-approval, hit the market, pre-approval, hit the market.
So as we move rapidly to an era when AI robots will be making moral decisions, life or death decisions, do we need regulation in this space? Or sort of a code of conduct or ethics for programmers and others who are, and technologists who are writing these programs that could potentially decide, whether you swerve one way or another on your self-driving car?
I think the first thing that'll happen that's like that is if the data that trains them is biased, you could be making some implicit moral decisions in that algorithm. So not like it's saying why, but the what or the how are kind of driven by the data. And at the ACR, we're looking at that and are concerned about that, and have patient advocates as well helping us to look at these things. I'm not sure if the regulators are in that space yet.
Yeah, I was going to say, I mean, that's an interesting challenge when we talk about sort of biased data, and that the fact that all of these things are trained, the systems are designed by people, they are trained on data that was probably generated in some way by people. There is bias in every single stage of the pipeline in building these things. And I don't necessarily mean bias as in some like prejudicial, but just statistical bias. Lots of different kinds of bias exist. But even in medical or biomedical data, there are cases where they've taken the exact same sequence of the data sets or the same kinds of scans, but from different machines. And then they had people train and do analysis on them, and they came up with different results. So even people who train data, train these models, you may have a model that disagrees. What do you do if I have, how do you regulate models like that? Like, what are the thresholds? What are the considerations? How do you manage this? How do you handle training? There's a lot of aspects that are really hard to pin down.
And I mean, I do natural language processing. We do actually have prejudicial biases in our training data and the things that we deal with. When you look at the big open models in NLP right now, the ones put out by Stanford or by Google, those have really well-known race and sex biases in them. Google's big example is man is to woman as king is to queen. If you move that and you say man is to woman as engineer is to, it will fill in, Google's model will fill in housewife. And that's a problem, right? And if you look at Stanford's model and you're using it to do restaurant review recommendations, it's going to, if two restaurants on the face of it, one's Italian, one's Mexican, the Mexican restaurant's going to get recommended less often. So, we've been out there, we've been doing a lot of work on measuring these things and removing them from our models and putting out models that other people can use that have them removed and just measuring that. But I think outside of basically hospitality where it has a business impact, we haven't seen enterprises say, hey, I'm glad your models are debiased, right? It's an incredibly internal thing.
So with the Google example, where does that bias come from? Does it come from because there are so many men? Sorry, go ahead.
The internet. It comes from the internet.
So is the algorithms are actually learning from the internet, or it's because?
Well, I mean, Google's models are all trained after essentially what's called the common crawl, which means all the data on the web, right? And if you think of all the data on the web, you think of what happened to, say, Microsoft Tay, you think of all these things. All the data in the web, it's not a happy place to be.
There's also,
So I was just, could you explain what happened with that Microsoft chatbot a little bit? 'Cause, I mean, that's an interesting example. It's also kind of.
Yeah, I can take this. So I don't know if you guys remember, sometime about earlier last year, Microsoft decided to release a Twitter bot that was supposed to represent a 19-year-old woman, and it was like, hey, I'm going to talk to you, you can talk to me, and I'm going to learn to interact. And the theory was people are going to talk to this bot in the way they would talk to a person like a friend, and it would learn dialogue, it would learn interaction stuff. But this being the internet and Twitter in particular, they had to shut the project down in 24 hours because it started from being like a friendly, like, hey, how's it going, to spewing racial epithets. And so the danger of sort of just letting these systems learn interactively, unchecked, is very dangerous.
And that was really the first example of what we would see and what we call in sort of the industry conferences as adversarial attacks on AI. And the reason that happened is because bulletin boards on the internet went there and made a concerted effort to say nasty things to the chatbot, right? So it picked up those nasty things. And that was a lot of what happened. And so when we think about learning models and adapting models, especially in certain contexts, you got to really say what happens if there's a concerted attack.
Anything else to add on that?
I was just going to say, like, again, to the point about the word embedding example and training on Google. So Google, these models, is trained on internet news articles. That's this view of what words are and what they mean. Sentiment analysis models are trained on things like movie reviews. So it's like, hey, we've got this great sentiment analyzer. It's good at picking out, the sentiment of a particular word, but it's trained on this corpus, and then you're trying to apply it to a different corpus, like, say, biomedical text or dictation. And this is a very different vocabulary. It's a very different structure of thing. And so suddenly these models don't really work as well. So it's also important that even though some of these models work really, really well, they pick up the fact that the data they're working from is in some sense inherently censored or truncated. It is not a full representation. It's really, really, really important, I would say, when doing any of these things, is to understand where your data comes from and sort of the implicit biases and ramifications of that.
What in terms of the bias question, have you seen any evidence of that in the medical space and problems and some solutions to address that, especially when it comes to hospitals and patient care?
So the way I look at this, and it was the way you described general AI and narrow AI, and it gets back to ethical, at least for me, we have to answer top-down questions. So why are we doing healthcare? Right? It's pretty clear why we do healthcare. I don't need to explain that. So how do you do healthcare? Well, the way that we do healthcare is we try and find those maladies, those diseases, by detecting them and then treating them to improve outcome, to improve patients' lives. So what do you do to do that? And that's where we are now leaning into AI. We do this by detection, by classification, by structure. So if we narrow our scope down to the lower level of those decision-making processes, I think you have less bias. You have the ability to gain less bias. If you do general AI, where you're saying, how do you want to treat this? Just read a textbook and you figure out how and figure out what. There's a higher level of accountability from a moral standpoint of who gets treated, how they get treated, what the impact is. And in a good way, I know everyone doesn't necessarily love regulators, but in a good way, that's where regulatory has a much higher threshold of approval as opposed to the lower level detection algorithms.
So, of course, we're in Boston. You all are products of Boston higher education. There seems to be a lot going on in AI in the city, and there's a lot of money being spent on AI as well from all the big tech companies investing heavily. What do you see as the potential for this going forward in Boston in particular? Is it becoming a cluster? Is it becoming a hotbed of AI research and startups?
I guess one way to talk about this is to sort of do in contrast to the other city where people like to talk about this stuff a lot. So how do we compare to sort of the ecosystem in the Bay Area, San Francisco? And I can tell you, we have to go out there, and not because maybe we want to, but because there's a tremendous amount of enthusiasm. People just try things. People are excited about things. People are much more willing to adopt and take a chance on new, crazy technologies we found. They really like to talk about this stuff. They really get enthusiastic. Boston is not like that.
I mean, I love Boston. I really love Boston. I can frame it a little bit differently, and when I talk to the press about Boston, I love to frame it a little bit differently. We're very grounded here.
Is that another word for boring?
Pragmatic.
No, pragmatic, yes, exactly. So I think Boston is a lot more enterprise focused. We don't make a lot of apps here. We don't have a lot of VCs who get very high valuations on products that haven't even hit the market yet. It's a very different ecosystem. It's a very traditional SaaS, traditional enterprise, metrics-driven ecosystem here. And I think that's frankly a little bit good for enterprise AI. We have a lot of people who have been in the industry for a while doing speech recognition or RPA or something here, and it's a lot more practical.
I would say, and I'm curious what the other panelists think, but as we started AI in healthcare, I thought the biggest problem was going to be to the data science part. And I'm not saying that's trivial by any means, but what you realize next is it's a data engineering part. So to be able to structure and organize your data, and then if you're implementing into an iPhone, it's one thing. If you're implementing it into an entire electronic health record of one hospital or 20 hospitals or an ecosystem across the United States, that's a massive undertaking. And all of a sudden, the data science part of it becomes a pretty small part of the challenge. So I think from my experience with General Electric moving into town recently, with all the activity that's going on in Cambridge, it's easier for me in this environment to think through the start to end activity that's necessary and be able to pull that together here in the city as opposed to other places.
Curious to know, thinking about where AI is going, where robotics is headed, is there an application for AI maybe in a space that's not, where it's not currently being applied, that you think is sort of ripe for some innovation for any of you?
I mean, it's, again, if you follow some of the plethora of AI startups, people are just trying to throw AI at anything and everything they can, even if AI is literally just a rebranding of an existing tool. And oh yeah, hey, look, we used scikit-learn to do a logistic regression. It's AI. Areas. I mean, we're seeing it in places. I'm trying to think of like areas where it's been actually really transformative in some cases is in looking at data. Like you mentioned, these affordances, things we couldn't do before, and that was dealing with like very, very large amounts of data, and especially things like geospatial data. So there are startups that are saying like we can do really fascinating analysis on, say, agricultural trends over decades by just looking at lots and lots of spatial satellite photos. Same thing with, like, we can start to estimate things like poverty in parts of the country that you could not get to before easily. So it's really unlocking a tremendous amount of analytics and sort of trend analysis that we just couldn't do before. And that's something I find is a really fascinating application of this.
How about you, Catherine?
I was also going to say agriculture. I think that when one thinks of farming and agriculture, one doesn't think that this is going to be the cutting edge of artificial intelligence, but so much has been done in manufacturing and agriculture that's really been transformative with machine learning, and it's happening incredibly fast. And it's all the way down to being able to have something that in mass looks at seedlings and is able to say, look, these seedlings need precisely this much fertilizer to have the outcome that you want. That's really going to change things.
So I see, let me speak to some of the challenges of it coming into healthcare, and maybe that translates to other disciplines. Right now, if you were a clinician and you said, I want to apply this AI stuff to my space, you have to go get some sort of compute capacity, You have to acquire all of your data. You have to structure and organize your data. You have to then hopefully get a successful outcome of an AI model. You have to implement that, and then you have to demonstrate the value. You have to go through regulatory approval, hire a sales force, go to commercialization. All of that, many, many parts of that are very repetitive and could be available as a commercial product that I could then use and innovate and be able to deliver both sides. We're not there yet today. So as the AI industry at large says there's an opportunity in this space, like it clearly has said for automotive, and it's starting to say for healthcare, if those tools get made, someone described it as basically the data is the code as opposed to the humans creating code 10, 20 years ago. But we don't have any data editors today. We have a compiler, but it's changing all the time. So we need to think of how to create these solutions that will optimize the data engineering part, simplify that for people, and then I think you'll see it start to proliferate faster.
So we want to bring the audience into the conversation. If you have questions, I think we have people with the mic, and we can talk about anything you'd like. I think there's one question back there. Maybe we'll talk about your favorite AI dystopian movies. We talked earlier about who saw Blade Runner or Ex Machina. Yep.
I really did like the movie Blade Runner, but I have a couple problems with data. I think my data belongs to me. My data does not belong to Google. I get upset when I see my personally identifiable information that I didn't put there with my personal name, age especially, and private phone number. And I feel like there's more borders in the US than there are outside the US lately. I mean, as a border resident, why should I have to choose one district or another district? Again, related to data. Why is it, homeless get to choose anywhere? Healthcare, why is it I can't go over to Rhode Island if I want to be in a clinical trial for something, and I can't do it because, oh, well, that's another border. It's exactly like that grid behind you in terms of like the data, where I can go, where I can't go. I don't know. I'm besides it myself. Thank you.
So I hope I could not even make sense of what you said, so probably indicative of what you guys heard from us. So
Clear out there.
Is it clear out there?
Yeah, in fact, she might say it again and we can walk on the other side.
Okay.
We're getting a lot of echo up here. I don't know how much you guys can tell that.
I couldn't hear up there, but maybe if she repeats it, I could hear it here.
You can't hear me. Now can you? I'm loud. Basically, she was saying that there are so many borders around in the US, and that why aren't there more borders for data, and that you were upset that basically some of your data that you have given to Google, you see a lot out there, and that is troubling.
So is the question, how do you fix that? Or like in healthcare in particular, see the challenge in healthcare, if a hospital is the repository of your data, you would probably not want that data to be given out without your consent. And, well, okay, can you have her repeat it? Thank you. It's so echoey up there, I couldn't hear anything.
Yeah, we actually have to wrap this up anyway, so we'll come down to you if you want to talk more, because I think the audio will be a lot better without these microphones and down there. So thanks very much for coming. And
Sorry.